Let us learn the properties of inverse trigonometric functions. The first set of formulae, sine inverse of x will become x, and this is true when x belongs to closed interval -1 to 1, which is the domain for sine inverse function. Then cos of cos inverse of x also becomes x for all x belonging to the closed interval -1 to 1. Then tan of tan inverse of x is x where x belongs to R. And then cot of cot inverse of x is x for x belonging to R. And cosecant inverse of x is x for all x belonging to R minus open interval -1 to 1. Similarly, secant of secant inverse of x is x for all x belonging to R minus open interval -1 to 1. So function and inverse functions will get cancelled. It becomes an identity function. Next set of formulae, sine inverse of sine x. Here we have inverse trigonometric function outside, trigonometric function inside, will become x only when x belongs to the principal value branch. Otherwise, we cannot cancel sine inverse function and sine function. Similarly, cos inverse of cos x. In the previous formula, we had trigonometric function outside, inverse trigonometric function inside. Here it is the other way around. So this is possible. You can cancel cos inverse and cos only when x belongs to the principal value branch of cos inverse, which is closed interval 0 to pi. Then tan inverse of tan x. Tan inverse and tan could be cancelled and it becomes x only when x belongs to the principal value branch of tan inverse, which is open interval -pi/2 to +pi/2. Then cot inverse of cot x becomes x when x is in the principal value branch of cot inverse, which is open interval 0 to pi. And then cosecant inverse of cosec x will become x only when x is in its principal value branch. The principal value branch for cosec inverse is closed interval -pi/2 to +pi/2 -0. And then secant inverse of secant x will become x when x belongs to the closed interval 0 to pi -pi/2. Next we will learn reciprocal properties, that is sine inverse of 1 by x will become cosecant inverse of x, where x is greater than or equal to 1 and x less than or equal to -1. Or we can combine and write this as absolute value of x greater than or equal to 1. Then next formula, cos inverse of 1 by x is equal to secant inverse of x. Same condition. Or we may write absolute value of x greater than or equal to 1. Then the third one, tan inverse of 1 by x will become cot inverse of x only when x is positive. This condition is important. You can use this reciprocal property only when x is positive. This is because The principal value branch for tan inverse function is minus pi by 2 to plus pi by 2 open interval. And for cot inverse, the principal value branch is open interval 0 to pi. And the common region is the first quadrant. So only in the first quadrant. So only when x is positive, we can write tan inverse of 1 by x as cot inverse of x. Then the next set of formulae. We can prove all these formulae using substitution. Sine inverse of minus x is minus sine inverse of x, where x belongs to the closed interval minus 1, 1. In the previous exercise itself we saw for negative values the angle is going to be negative, fourth quadrant angle, no, because the principal value branch for sine inverse is closed interval minus pi by 2 to plus pi by 2. Tan inverse of minus x. Again the principal value branch for tan inverse is also minus pi by 2 to plus pi by 2 open interval. Therefore for negative values, negative angle, which is the fourth quadrant angle, so minus tan inverse of x, where x belongs to R. Then cosecant inverse of x, cosecant inverse of minus x is equal to similarly minus cosecant inverse of x for absolute value of x greater than or equal to 1. For all these three inverse trigonometric functions, the principal value branches are minus pi by 2 to plus pi by 2, fourth and the first quadrants. So for negative values we write the negative angle, which is the fourth quadrant angle. Now for cos inverse of minus x, if the value is negative, it is going to be the second quadrant angle. For positive values, first quadrant angle we write. For negative values, we write the second quadrant angle. So pi minus cos inverse of x. For x belonging to closed interval minus 1, 1. And then secant inverse of minus x is equal to same thing, pi minus secant inverse of x, where absolute value of x is greater than or equal to 1. Cot inverse of minus x. For cot inverse also the principal value branches first and the second quadrants. Therefore pi minus cot inverse of x, where x belongs to R. For these three functions, the principal value branches are 0 to pi, first and the second quadrants. For positive values, we write the first quadrant angle. For minus x, for negative values, we write the second quadrant angle. Second quadrant angle, we write it as pi minus the base angle. That's why we have pi minus cos inverse or pi minus sec inverse or pi minus cot inverse of x. Then next set of formulae. Relation between the inverse trigonometric functions. The first one is sine inverse of x plus cos inverse of x is pi by 2. Again, this can be proved easily by substitution. Similarly, tan inverse of x plus cot inverse of x is also pi by 2. And here x belongs to minus 1, 1. And here the domain for tan inverse and cot inverse is R. And then cosecant inverse of x plus secant inverse of x is also pi by 2. X belonging to R minus open interval minus 1 to 1, or we may write it as absolute value of x greater than or equal to 1. Then the next set of formulae, tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus xy. And this formula is applicable only when x into y is less than 1. So you check this condition. When the condition is satisfied, then you can use this formula. And then the next formula, tan inverse of x minus tan inverse of y is equal to tan inverse of x minus y by 1 plus xy. Very, very important formula. And here the condition is xy greater than minus 1. So check these conditions. If the conditions are satisfied, then you may apply the formula. And then 2 tan inverse of x formula. We have 3 formulae for 2 tan inverse of x. One is using sine inverse, which is sine inverse of 2x by 1 plus x square, and the condition is absolute value of x is less than or equal to 1. And another formula in terms of cos inverse 1 minus x square, cos inverse of 1 minus x square by 1 plus x square, where x is greater than or equal to 0, and tan inverse of 2x divided by 1 minus x square, minus 1 less than x less than 1. So we have 3 formulae for 2 tan inverse of x. All these 3 formulae can be proved using sine 2 theta formula in terms of tan, cos 2 theta formula in terms of tan we have. Similarly, tan 2 theta formula. So using these formulae we can prove them. You have to be thorough with all these inverse trigonometric formulae. Not only inverse trigonometric formulae, even trigonometric formulae you should be thorough with. Example 3. Sine inverse of 2x into root of 1 minus x square. We have to show that it is equal to 2 sine inverse of x, and the condition given is minus 1 by root 2 less than or equal to x less than or equal to 1 by root 2. Let us substitute x as sine theta. The answer is given in terms of sine inverse of x, so I am taking sine theta substitution. Therefore, the left hand side becomes sine inverse of 2 sine theta into root of 1 minus sine square theta. Sine inverse of 2 sine theta root of 1 minus sine square, identity we have, it becomes cos square theta. We get sine inverse of 2 sine theta cos theta. And this formula is sine 2 theta. Now sine inverse and sine can be cancelled only when 2 theta is in the principal value branch. So we have to check. The condition given is x is less than or equal to 1 by root 2 greater than or equal to minus 1 by root 2. But our x is sine theta. So in place of x I am substituting sine theta. So sine theta is less than or equal to 1 by root 2 greater than or equal to minus 1 by root 2. This is the given condition. Now let us take sine inverse throughout. Sine inverse of sine theta will become theta, and sine inverse of 1 by root 2 is 45 degrees, and sine inverse of minus 1 by root 2 according to the principal value branch it is minus pi by 4. But we have to check for 2 theta whether it is in the principal value branch or not. So multiply throughout by 2. Pi by 4 into 2 will become pi by 2, less than or equal to 2 theta, less than or equal to pi by 2. Now 2 theta is in the principal value branch of sine inverse, because principal value branch for sine inverse is closed interval minus pi by 2 to plus pi by 2. We know it comes under the principal value branch. That's how sine inverse and sine could be cancelled. Therefore, the answer becomes 2 theta. Now substitute for theta. Theta is sine inverse of x. And this is the right hand side. Now see the second subdivision. We have to prove that sine inverse of 2x into root of 1 minus x square is 2 cos inverse of x. The answer, the same question, but the previous answer was in terms of sine inverse of x. Here it is cos inverse of x, and the condition given is 1 by root 2 less than or equal to x less than or equal to 1. Now here I am going to substitute x as cos theta because my answer is in terms of cos inverse of x. Don't substitute x is equal to cos x. You cannot use the same variable. Okay, substitute x as cos theta. Many will do that mistake. That's why I am saying that. Now the left hand side becomes sine inverse of, let us substitute. I am writing the left hand side first. Substitute x as cos theta. So it is 2 times cos theta root of 1 minus cos square theta, which becomes 1 minus cos square is sine square and root of sine square is sine theta. Now this is sine inverse of sine 2 theta formula. Now sine inverse and sine could be cancelled only when 2 theta is in the principal value branch. Let us check. The condition given is 1 by root 2 less than or equal to x less than or equal to 1. Let us substitute for x. X is our cos theta. Let us take cos inverse throughout. Cos inverse of 1 is 0 and cos inverse of this is pi by 4. And you have to reverse the inequality because as the angle increases in the first quadrant, cos decreases. So we have to reverse. Otherwise also you can make out. Look at the value. 0 here, pi by 4 here. So you have to reverse the inequality here. But we have to check for 2 theta. So let us multiply throughout by 2. Pi by 4 into 2 is pi by 2. And this is 2 theta greater than or equal to 0. 0 to pi by 2. Yeah, 0 to pi by 2 is the first quadrant. Principal value branch for sine inverse is minus pi by 2 to plus pi by 2. But 0 to pi by 2 is a subset of this principal value branch. So we can cancel sine inverse and sine as 2 theta lies in the principal value branch. Now substitute for theta. From here, theta is cos inverse of x. So 2 times cos inverse of x, which is the right hand side. So for these simplification of inverse trigonometric questions, you have to be thorough with trigonometric formulae as well. Now exercise 2.2. First question. Prove the following. 3 sine inverse of x is equal to sine inverse of 3x minus 4x cube, where x belongs to minus half to half. By looking at the expression, you can make out this looks similar to 3 sine theta minus 4 sine cube theta formula. So let us substitute x as sine theta. I am taking the right hand side. Sine inverse of, in the right hand side, let us substitute x as sine theta. So 3 sine theta minus 4 sine cube theta. And this is the formula of sine 3 theta we know. Now sine inverse and sine could be cancelled only when 3 theta is in the principal value branch. Let us check whether 3 theta is in the principal value branch or not. The condition given is x is less than or equal to half, greater than or equal to minus half. X is sine theta substitution we did. Let us take sine inverse throughout. This becomes theta. Sine inverse of plus half, first quadrant angle, which is pi by 6, and for minus half we get minus pi by 6, because principal value branch for sine inverse is minus pi by 2 to plus pi by 2. For negative values, negative angle. Let us check for 3 theta. Multiply throughout by 3. So minus pi by 2 to plus pi by 2. So 3 theta lies in the principal value branch of sine inverse. So we can cancel sine inverse and sine, because 3 theta is in the principal value branch. Now substitute for theta. From here, theta is sine inverse of x. Therefore the answer becomes 3 times sine inverse of x, which is the left hand side. Second question, we have to prove that 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x, where x belongs to the closed interval half to 1. It is a similar question. We can, from this expression, we can make out that it looks similar to cos 3 theta formula. So let us take x as cos theta and substituting for x on the right hand side. Cos inverse of 4, x cube becomes cos cube theta minus x becomes cos theta. And this is the formula of cos 3 theta. Now cos inverse and cos could be cancelled only when 3 theta is in the principal value branch. So let us check. The condition given is half less than or equal to x less than or equal to 1, closed interval. But x is cos theta. Let us take cos inverse throughout. Cos inverse of 1 is 0. Cos inverse of half is pi by 3. We have to reverse the inequality when you take cos inverse in the first quadrant, especially when the angle increases in the first quadrant, the value of cos decreases. Otherwise also you can make out from the values I said, 0 and pi by 3. Now we have to check whether 3 theta is in the principal value branch or not. So let us multiply throughout by 3. 0 to pi is the principal value branch for cos inverse. Now cos inverse and cos could be cancelled. We get 3 theta. Let us substitute for theta. Theta from this is cos inverse of x. Therefore the answer becomes 3 cos inverse of x, which is the left hand side. Question 3. Tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. We are going to make use of this formula. Tan inverse of x plus tan inverse of y is tan inverse of x plus y by 1 minus xy. Please memorize this formula along with the condition. Xy should be less than 1. Check this condition is satisfied or not. 2 by 11 is our x. 7 by 24 is our y. Yeah, it is less than 1. So I can use this formula. Therefore, the left hand side becomes, I am taking the left hand side. Let us use this formula. It becomes tan inverse of 2 by 11 plus 7 by 24 divided by 1 minus 2 by 11 into 7 by 24. Let us take LCM and simplify. LCM will be 11 into 24. 48 plus 77 by 264. 11 times 24 is 264 minus 14. The LCMs will get cancelled. We get tan inverse of 125 by 250. Tan inverse of half. And this is the right hand side. Question 4. Prove that 2 tan inverse of half plus tan inverse of 1 by 7 equal to tan inverse of 31 by 17. We have formula for 2 tan inverse of x. We have 3 formulae in terms of sine inverse, cos inverse and tan inverse. I am going to use tan inverse formula because the other term is in terms of tan inverse. Tan inverse of 2x by 1 minus x squared. Let us use this formula. The left hand side becomes tan inverse of 2 into half divided by 1 minus x squared. And the second term is tan inverse of 1 by 7. Let us simplify this. 1 minus 1 by 4 is 3 by 4. If I write the reciprocal, it becomes 4 by 3. Plus tan inverse of 1 by 7. Now next I am going to use tan inverse of x plus tan inverse of y formula, which is tan inverse of x plus y divided by 1 minus xy, and the condition should be xy less than 1. Check whether the condition is satisfied. Our x is 4 by 3 and y is 1 by 7. Yes. Product is 4 by 21, which is less than 1. I can apply this formula here. 4 by 3 plus 1 by 7 divided by product 4 by 3 times 1 by 7. Take LCM. LCM is 21. LCMs could be cancelled. We get 31 by 17, which is the right hand side. Now next question, we have to bring them to simplest form. So before bringing them to simplest form, you should know few types of substitution which we have to do. Write down this table and memorize. You can write down this table in your textbook, in NCERT textbook, page number 55. On that page you can write. If the function has this expression, substitute x as a tan theta or x as a cot theta. If you have root of a square minus x square, we substitute x as a sin theta or a cos theta, so that we can use the identity 1 minus sine square or 1 minus cos square. We have identities, right? That's why. Similarly, for the first one, we have identity for 1 plus tan square and 1 plus cot square. And root can be removed after using the identities. We can simplify the functions. If the function has root of x square minus a square, substitute x as a secant theta or a cosecant theta. If it involves the function root of a minus x by a plus x or root of a plus x by a minus x, wherever you have 1 plus or 1 minus or a plus a minus, we always substitute x as a cos 2 theta, because we have formula for 1 plus cos as well as 1 minus cos. Similar function, if you have a square minus x square divided by a square plus x square or root of a square plus x square by a square minus x square, we substitute x square as a square cos 2 theta. Same cos 2 theta substitution, but a square cos 2 theta, so that a square can be taken out. Remember these formulae. 1 plus cos 2 theta is 2 cos square theta, and 1 minus cos 2 theta is 2 sin square theta. Very important formula. Memorize this substitution table. Now question 5. Write the following functions in the simplest form. Tan inverse of root of 1 plus x square minus 1 divided by x, where x is not equal to 0. Since we have root of 1 plus x square, look at the substitution table which I gave. So 1 plus x square, we will substitute x as tan theta. Or you may substitute cot theta. Here a is 1, so a tan theta is 1 tan theta. Therefore the function becomes tan inverse of root of 1 plus tan square theta minus 1 divided by x is tan theta. This is equal to, we have identity for 1 plus tan square, which becomes secant square. And root of secant square theta is secant theta. Secant theta minus 1 by tan theta. Let us change everything in terms of sine and cos. Secant is 1 by cos theta and tan is sine theta by cos theta. Tan inverse of, I am taking LCM, 1 minus cos theta by sine theta. LCM cos theta will get cancelled. Now wherever you see 1 minus cos or 1 plus cos, use the formula which I gave. Below the table I wrote that formula. 1 minus cos is 2 sine square theta by 2. And similarly sine 2x formula, 2 sine theta by 2 and cos theta by 2. Sine theta by 2 divided by cos theta by 2 becomes tan theta by 2. And tan inverse and tan could be cancelled only when theta by 2 is in the principal value branch. But here no condition is given, so we can cancel it. Half into substitute for theta. From this substitution, theta is tan inverse of x. Therefore, half into tan inverse of x we get. So we have simplified the expression. Sixth question. Tan inverse of 1 by root of x square minus 1. And the condition given is absolute value of x is greater than 1. Let us substitute x as cosecant theta, or you may substitute secant theta also, but this will be better. We can reduce one or two steps. Tan inverse of 1 by root of cosecant square theta minus 1. We have identity which becomes cot square and 1 by cot becomes tan theta. Now tan inverse and tan could be cancelled if theta is in the principal value branch. Absolute value of x is greater than 1. That means x is greater than 1 and less than minus 1. X is cosecant theta. Let us find cosecant inverse throughout. Let us take. So this becomes theta. Cosecant inverse of 1 is pi by 2 and this is minus pi by 2. Now we have to change the inequality when we take cosecant inverse, because it is 1 by sine, no? So reverse the inequality, and it is the principal value branch of tan inverse. Principal value branch for tan inverse is minus pi by 2 to plus pi by 2 open interval. Therefore tan inverse and tan could be cancelled. It becomes theta, and substitute for theta. From this, theta is cosecant inverse of x. Question 7. Tan inverse of root of 1 minus cos x by 1 plus cos x. 0 less than x less than pi. Here there is no substitution required, because already inside we have trigonometric function, outside we have inverse trigonometric function. So no substitution required, direct simplification. 1 minus cos formula, wherever you see 1 minus cos or 1 plus cos, use the formula 2 sine square x by 2 and denominator is 2 cos square x by 2. Tan inverse of root of tan square x by 2. Root and square could be cancelled. Now tan inverse and tan could be cancelled only when x by 2 is in the principal value branch. And this is the condition given. Now we have to check for x by 2. Just divide throughout by 2. 0 by 2 is 0 and pi by 2. So 0 to pi by 2 is the first quadrant, which is a subset of the principal value branch of tan inverse. Principal value branch for tan inverse is minus pi by 2 to plus pi by 2. So 0 to pi by 2 is the first quadrant, which is a subset of the principal value branch. So I can cancel tan inverse and tan. The answer becomes x by 2. This is the simplest form. Tan inverse of cos x minus sin x divided by cos x plus sin x, and the interval is minus pi by 4 less than x less than pi by 4. In some editions it is given as 0 less than x less than pi. We will do with this condition, minus pi by 4 less than x less than pi by 4. Now tan inverse of x minus y by 1 plus xy. The formula is tan inverse of x minus tan inverse of y. To use this formula, I need 1 in this position. So let us get 1 here. To get 1 there, I have to divide by cos x. Therefore, the function becomes tan inverse of cos by cos is 1. Sin x by cos x becomes tan x. 1 plus tan x. And in the denominator, very well I can write it as 1 into tan x. And let us use this formula. So tan inverse of, in x place I have 1 minus y is tan x. So tan inverse of tan x. I am using this formula. Tan inverse of x minus tan inverse of y. My x is 1, y is tan x. Tan inverse of 1 is pi by 4. Tan inverse and tan could be cancelled only when x is in the principal value branch. Look at this condition given. This is the subset of the principal value branch of tan inverse. Principal value branch of tan inverse is minus pi by 2 to plus pi by 2. And here it is given minus pi by 4 to plus pi by 4, which is a subset of the principal value branch. So we can cancel. So the answer is pi by 4 minus x. Question 9. Tan inverse of x divided by root of a square minus x square, where absolute value of x is less than a. Let x be a sine theta. Therefore, the function becomes tan inverse of a sine theta divided by root of a square minus a square sine square theta. A square can be taken common. It becomes a outside, and 1 minus sine square identity will become cos square. Tan inverse of sine theta by cos theta it becomes, which is tan theta. Now tan inverse and tan could be cancelled only when theta is in the principal value branch. So we have to check absolute value of x is less than a. That means x is less than a, greater than minus a. X is a sine theta. This is our substitution for x. Let us cancel a throughout. Take sine inverse throughout. Sine inverse of 1 is 90. Sine inverse of minus 1 is minus pi by 2, which is the principal value branch of tan inverse. Therefore, we can cancel tan inverse and tan. It becomes theta. Now see this. From this, sine theta is x by a. So theta will be sine inverse of x by a. The answer becomes sine inverse of x by a. Question 10. Tan inverse of 3a square x minus x cube divided by a cube minus 3ax square. And the condition given is a greater than 0 and minus a by root 3 less than x less than a by root 3. strictly less than sine. Now if you look at this expression, it looks like tan 3a formula. Therefore we are going to substitute x is equal to a tan theta. Therefore the function becomes tan inverse of 3a cube tan theta, a cube tan cube theta divided by a cube minus 3a squared. So a cube tan square theta. Now we have a cube common in both numerator and the denominator. I am taking a cube out. 1 minus 3 tan square theta. Now this is the formula for tan 3 theta. Now tan inverse and tan could be cancelled only when 3 theta is in the principal value branch. So let us check. The condition given is this. Now x is a tan theta. I will write here a tan theta is less than a by root 3 and greater than minus a by root 3. Cancel a throughout. Take tan inverse throughout. Tan inverse of 1 by root 3 is pi by 6 and here it is minus pi by 6 because principal value branch for tan inverse is minus pi by 2 to plus pi by 2, so negative angle. Now 3 theta. We have to check for 3 theta. Let us multiply throughout by 3. Minus pi by 2 to pi by 2, which is the principal value branch for tan inverse. Now 3 theta is in the principal value branch of tan inverse. So I can cancel tan inverse and tan. It becomes 3 theta, which is 3 times tan inverse of x by a.